In this video, we are going to discuss about practice 3. The last video we discussed about practice 1 and practice 2. So today we'll discuss about some component, some connection of component, some connection of some electric components. Among those components, we'll discuss about what we call energy meter and what we call circuit breaker. So when we say about energy meter, that is the machine or the apparatus that measure the energy. And we know energy equal the power multiplied by the time where the element was running. Now when we say about circuit breaker, that is protective element. That used to protect the circuit when current exceeds. Let's say, for example, we have a circuit breaker that the maximum current is 5 ampere. So when a current exceeds 5 ampere, the circuit breaker will break the circuit. So it will turn off. The circuit, because the current which was trying to enter is greater than the maximum current, the rate current of the circuit breaker. So we have the energy meter also. But before we go to the energy meter, we have to know the concept of AC. When we say about alternative current or alternative voltage, it has like this symbol. So in this symbol, when we have in AC, it has positive and negative, and this positive and negative terminal, it can also change to be positive and negative in the opposite side. When you have like this one, sometimes the positive terminal will be here and the negative terminal here. Another circle, here will be the positive terminal and here will be the negative terminal. So now when we come for the energy meter, let's say for example, it has a display here. This display will show you the energy consumed. Let's say for example 32 kilowatt hour. And when I know the energy consumed, I can determine the total cost. Because when I'm going to buy my energy meter, the manufacturer will tell me, let's say for example, the tariff. And tariff, let's say for example, $0.7 per kilowatt hour per unit. So mean that I already know that in 1 kilowatt hour, I know it is $0.7. Now, if my energy meter display 32 kilowatt hour, I can directly determine the cost that I have to pay by 0.7 multiplied by 32. Now, here to show my display, I have also this part. This part has like 2 terminals here, another terminal here. The first part here was to show 1, 2. This come from the supply. Now from the other here come from the load. We'll go to the load. Now here will be my supply. It will pass from here, and here in the other side will be my load. We'll get to my load. Now if we see, we'll see that there will be, since I have two single phase, I have 2 wires. I will have the red one here and the black one. But since the supply, the current or the voltage will be here, it is AC, it's not matter. Here I can also put my red here, I can also put my black here. Why? Because it is AC. The positive negative, it can use to change. The polarity used to change. So here can be the positive, here also can be the negative. So it's not matter. I can put my red here, I can put my red here, but here it have to be from the supply. Same as here. Here can be my live, here can be my neutral. But since the voltage or current will be here, which is AC. I can also put my live here and my neutral here. Why? Because sometimes the positive can be here, the negative to be here. Sometimes also the positive can be here, the negative to be here, because it is AC, the polarity change. So something, if we used to see in the switch, in the socket we used to have some socket of 3 terminal. We discussed in the previous practice that here used to be my earth for protection. Here can be from the live, and here can be from the neutral. But since the voltage will be here, it is AC, same thing here can be my neutral, and here can be my live, because polarity will change. Sometimes here it will be my positive, sometimes here it will be my negative, sometimes it will be my negative, sometimes it will be my positive. That's why it's not matter if we put here the live or we put here the neutral. Here you have to be the earth. That's why sometimes when you are going to plug the charger, it's not matter if you put here, you put here. It's not matter. You can change it again. If you change it again, here to be here is not matter when you are going to plug the charger, because it doesn't care about the polarity here. Why? Because it is AC. The polarity will change. Now, let's see about the circuit breaker and the energy meter and practical components. We have let's say, for example, we have this one is the energy meter. The energy meter always the energy meter, it will measure the energy consumed, let's say, by the house. So the energy meter have to be connected to the entering of the electricity, have to be connected to the entry of the electricity. That's why sometime in a house we used to see the energy meter is connected when in the first door when you're entering the house. Why? Because it's going to measure the energy consumed by the whole house. But if, for example, let's say, for example, I have this house. If I want to measure the energy consumed by the total house, I will put the energy meter here, since the entering of the supply is from here. But let's say, for example, this house has different rooms. I want to measure the energy consumed by this room. I will put the energy meter here, another energy meter here. Why? Because the entering supply of this room is entered through this energy meter. Same as in this room, I can put the energy meter here to measure the energy consumed by this room 2. But when I want to measure the energy consumption from the whole house, I will put the energy meter here to measure the energy consumed by the whole house. Now, if you see, it has like 4 poles. As we say, the first terminal here is going to be the supply, from the supply. So we already discussed that it's not matter if I put the supply, the live here and the neutral here. I can also put the neutral here and put the live here. It's not matter, because the voltage or current will enter here. It is AC. Now I have from the supply here. The other side is going to be from the load to the load. I can also put the neutral here and put the live here. Is not matter, because it is AC. Now I already connect the energy meter. Now we know this is the circuit breaker. The circuit breaker is used for protection. When there is some reading here, let's say in this reading we have 40 ampere, mean that when this current entering the whole house exceed 40 ampere, mean that all circuit will trip. It will shut down. because the current is exceed the 40 ampere, the rating of this circuit breaker. Now we are going to connect the circuit breaker for protective in case if the electricity exceed 40 ampere. There is different type of circuit breaker. Now let's see. I have two terminal also in the circuit breaker. I have this terminal here. I have another terminal here. Now if I connect the live from here, mean that the negative terminal will be connected to here. So something, this line is connected to here again. This line is connected to here. I have to take another line from here, another line from here, and take the neutral from here, this side. Now I take this line or this neutral. Let's say I connect it to here for another MCB, another circuit breaker, and I connect this one to here. Now same thing, this is going to be connected from here, same thing, this live, and the neutral connected to here. Now let's see, the neutral will be connected from here. Here, if you see in this two circuit breaker, it is double pole. Double pole means that it will be connected with the live and the neutral. But if we check this, we check from this circuit breaker is SP, single pole. Why? Because it is not connected with the neutral, only will be connected with the live. So we have, based on the pole, we have two type of pole. It can also be three type, but we have the single pole and we have double pole. The double pole will be connected with the neutral and the live, while the single pole will be connected with the live only. Now we have all another this circuit breaker but single pole. This single pole will be connected to the live. So the live will be connected from this, another live will be connected to this, to this. Now another live wire will be connected from here, another live 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 will be connected from here. Now let's see, this live will go to room 1 or block 1. This live will go to room 2. This live will go to room 3. This live will go to room 3, room 4. Now I have different room. The different room will be protected with each circuit breaker. This room will be protected with this circuit breaker. This room will be protected with this circuit breaker. This room will be protected by this circuit breaker. Now let's see. We have the reading here. We have 10 ampere, mean that if the current is going to this room exceed 10 ampere, this will trip. This one will be off. All room will be off because the current exceed the rating of this circuit breaker. That's why if, for example, you put a high load here in this room, you put high load here or in this block, when the load supposed to get a high current and then rating of the circuit breaker, all block or room will shut down. Why? Because the load are more needed in current than the rating current that of this circuit breaker. Same as this room, same as the here. That's why, for example, if we are, let's say for example, we are in this level, we have different room, but this one is off, is shutting down this block. The other is working. It's not problem because you know now, we know directly that because here the circuit breaker is trip off. Why? Because here we exceed the limit, so we have to go to remove the load and to on again the circuit breaker, so and remove the load, because if we do not remove, something will be happen again. So we have to be careful about our load. Now same thing of this room. This room we have C6, we have 6 ampere. We should not exceed this rating of this circuit breaker, same as all other rooms. Now let's say for example we have 40 ampere here. The 40 ampere here have to be, we remember case L have to be the summation of this one plus the summation of this one, summation of this one, summation of this one, summation of this one. Have to be the summation of this one. Now let's see, if all room are shutting down, it means that the problem will occur here, because all room there is no electricity, mean that the problem will occur here in the main circuit breaker. In the main circuit breaker. But if only one room mean that the problem is not from here, but the problem from this circuit breaker. Now let's see here. We are going to see some example. We are going to see some example. In this example, let's say we have this example. In this example, we are going to do the house wiring. In this example, house wiring. Now we know our live come from here. Live. This is our live, and our neutral come from here. We have two wires. We are going to connect from here. Now this let's say for example this neutral will be connected from this terminal. Someone who can connect this neutral to this terminal. It's not matter, because it will be AC here. So if I connect from here, is not matter. But both live and neutral I cannot connect from here, because here it will be my earth. Now the live I connected to here, and I connected to here, and I connected to here, and I connected to here. This one, 3 different switches. So now this potentiometer or this regulator, we already discussed in the first video of our practice. We see about the regulator. The regulator is control the speed of our fan. So now this regulator will go directly to positive terminal of our fan from here. Now I have this also. This one is our switch. I can connect this switch, control this switch to this lamp, and another switch from here is going to be connected to the positive terminal of this lamp. Now remind this switch, we know there is some socket that is controlled by a switch here to on or off the socket. So mean that this socket will be connected from here to the other terminal of our socket. Why? Because this one is I connected the neutral. Here I'm going to connect the live. I cannot connect the live from here, because here we see the previous video is going to be from our earth. Now someone else can connect the live to this one. If we connect it from this terminal, the neutral will be connected to here. It's not matter, because this AC will come in this switch, in this socket. Now I connect it from this one to this one. Now only the neutral remain. The neutral I just take from here a node. From here we see in our theory the node, what is node mean, and I can connect also from here to here directly to this one, and I can connect from here again, or here to our fan. Now remain the live. This live will be connected with usually with a yellow pen. This not yellow, this green will be connected to our earth, or we can come to here. Now this our small of house wiring. We have 2 wires. We have the live be connected to this regulator. We'll check for the other terminal of the regulator to our fan. Now we have this switch. The switch will control this lamp, and we have the other switch will control this lamp, and we have another switch connected to this socket. This switch I will take from here, since it's connected, the supply connected from here to here. That is an example of small example of small room house wiring, small room. Now let's say, for example, someone we're going to add a component here, let's say a TV here. Most of the TV is connected to a socket. So you just sell our socket. The socket have three terminal. I can connect the live to here, is not a problem, or to connect the live to here is not a problem, and to connect the neutral to here, and to connect the earth to here is not a problem. The only thing we have to pay attention is only, like, for example, let's say, for example, the live is supplying 20 ampere. So we should not exceed more element such way that the element will want to have high current than the current that you used to be supplied. I hope everyone understand this video. Next video we'll discuss about